Let us look at this integral. It's the integral of x e to the x dx. Now, we can see that you have two functions in x that multiply each other. If you try to use substitution, it would not work. When you differentiate e to the x, it doesn't give you something that can cancel out the x. And when you differentiate x, it doesn't give you something that can cancel out e to the x. So you choose another method. What about integration by parts? Okay, with integration by parts, remember, the formula is the integral of u dv, right, equals uv minus the integral of v du. That's integration by parts. Now, let me make a few changes to this. The dv, u dv is equal to uv minus the integral of v du. Let me put the u in green and the v's in red. Alright? Now, here, which one do we use as u and dv? Let us first consider, what would I say now? One of them is u. You differentiate u. Suppose you consider e to the x to be u and x to be dv. How would things work out? Let us see. The integral of u, which is e to the x, dv, which is x, so it's u dv, is equal to u times v. Now, we're saying that u is e to the x, so this is e to the x times v. But guess what? Our dv is x. See that? So, to move from dv to v, you have to integrate. What you'd have is x squared over 2. Alright? Minus the integral of v, which is the same, x squared over 2 times du. Now, you moving from u to du. U is our e to the x. When you differentiate e to the x, you get e to the x. Now, how does that help us? It seems as if we're in more trouble than we started with. You see that? So you have to make a correct choice as to which one is u and which one is dv. Remember, you start with u. U is over here. Then you go to du. Make sure that whatever you use as u, when you differentiate it, it becomes simpler, not more complicated. Or the same as in this case. Our u is e to the x and the remainder e to the x. The other thing is, with the dv, you move from dv to v by integrating. You integrate one function. But the important thing to consider here in making the choice is which one you use as u, so that when you differentiate u, it becomes simpler. So we have to change our decision. Now, let u, and by the way, let me change the colors of the integral signs, and this minus and this. Okay, good. Now, suppose we consider u to be x, right? U is x, and dv is e to the x. What we're going to have is the integral of u, which is x, dv, which is e to the x, is equal to u still remains x times v. Now, to move from dv to v, we integrate, right? So our dv will remain e to the x. See that? Minus the integral of v, which is the same e to the x, times du. And the du now, that will be interesting. We have u equal x. To move from u to du, we have to differentiate. What do you get when you differentiate x with respect to x? You get 1. Alright? So this is 1. Now, things become simpler and we're on our way to solving it. So, what we have is that the integral of x, which is our u, times dv, which is e to the x, is equal to x e to the x. So we have our x e to the x minus, what's the integral of e to the x? It's just e to the x times 1, which you don't really have to worry about too much. So our answer is x e to the x minus e to the x, which we can write as e to the x in bracket x minus 1, right? Plus c. So there we go.